Hey everybody, this is another bonus video for understanding statistical process control. So what I want to talk about today is process capability, and really just want to talk about this in real basic terms. I want you to understand the concept today, not the math. This seems to be something that students struggle with, even though it's not very hard. I think sometimes the math gets in the way of developing kind of a deep gut level understanding of some of these concepts, and this is definitely one of them. So let's talk talk pretty basic here. So just kind of a review of the statistics. Remember, a lot of things in life follow a bell curve or a normal distribution, right? Most things are average, right? This would be the average. I mean, this could be like height of 18-year-old males, right? Most are going to be like maybe around 5'10", right? Some are going to be a little taller, some are going to be a little shorter. Not going to be a whole lot that are a whole bunch taller, a whole bunch shorter, right? It follows the bell curve. So that's kind of one of the most basic things to understand. And when we have the bell curve, we have the average, right? But the other important thing is the standard deviation, which we can think of as like how wide is this curve, right? We could draw the curve like this. There, the standard deviation is going to be really, a lot higher than on the curve to the left. Or, maybe the curve looks like that, right? And that is not very much dispersion around the mean, right? So standard deviation there is pretty low. The cool thing about standard deviation is that we know that about a third, about 66% of all observations are going to be within one standard deviation of the average. About 95% of observations are going to be within two standard deviations, and about 99.7% are going to be within three standard deviations of the average. So, again, if we're looking at, the height of 18-year-old males, most of them, about 2/3 are going to be within this range, right? So if we know what the range is, maybe the standard deviation is an inch, and if the average is 5'10", then we know that there, about 2/3 of them are going to be between 5'9" and 5'11", right? Because again, I said the standard deviation was about an inch, right? And we know that 99.7, or just about everybody, is going to be within three standard deviations. So let's see, if the mean is 5'10", then just about everybody would be between about 5'7" and 6'1", right? 6'1". Okay, and that's really the critical thing here is pretty much all. I'll just put all in parentheses here. Pretty much all the data, all the observations, all the points, all the people, if we're talking about this example, are going to be within that three standard deviations on either side of the mean. It's pretty unusual to see anything outside, three standard deviations. Okay, so as far as thinking about these statistical quality control concepts, you can just pretty much just convert this 99.7%. Just think about that as everything. Okay, more or less everything is going to be within three standard deviations. There's a really small probability of seeing anything outside. So just think about it as everything, or all the observations are going to be within that band. Okay, that's kind of the first important concept. So if we have a process of any type, and we know what the standard deviation of the process is, in other words, we know, how spread out the possible outcomes of the process are, then we can figure out what the probability is that that process will hit any particular target. So let's talk a little bit more about that. Okay, so let's take football, right? Good time of year to be talking about football. So let's say we've got field goal kickers, all right, potential field goal kickers. And we want to figure out whether or not a field goal kicker is capable. you know, in a statistical sense. I think I might have spelled that wrong, but you get the idea. So if that was the case, what we would do is we'd, let's see, you know, for this particular kicker, we'd stand this kicker out in a field someplace and, you know, maybe draw an imaginary line here, not really that important, and we just tell the kicker to start kicking footballs. Okay, so, you know, let's say his first football goes there, crosses the line there, second football maybe goes there, you know, third football goes there, fourth football goes there, another football there, another football there, another football there, and maybe we have a football over here, a football here, got a couple more back here, pretty close. Okay, you know, maybe we get another football out here somewhere. Okay, so you can see, you know, we're starting to get kind of a pattern, right? And it looks, you know, somewhat normally distributed, right? Actually, the mean's probably a little bit further over that way. Yeah, the average football, in other words, is probably right in here someplace. So the critical thing that we want to do now is we want to figure out what the average distance, we want to figure out each point's distance from like where the average football crossed the line, which is here, right? So we measure, you know, say the distance from this point over the average, the distance from this point over the average, and so on, right? And we can figure out what that is, okay? Let's say it's 2.5 feet, okay? So the average football, well, yeah, the average football is 2.5 feet from, you know, this point where most footballs cross the line, right? So I know just based on kind of a statistical rule of thumb that you know, if the average football is about is 2.5 feet from this point, right? In other words, again, the averages of all these distances are 2.5 feet, then the standard deviation is about 3 feet. Okay, now, students hate it when we start to talk about standard deviation, but you know, that's kind of maybe a little bit more intuitive explanation of what standard deviation really is. It's just the average deviation or the average distance, you know, between any particular point and the most common point. Okay, so the standard deviation is 3 feet. Okay, well, so we have some sense of, you know, how much dispersion there is in a kicker's kicks, you know, how spread out they are, right? Ideally, we'd want them all to be clustered, you know, really, really tightly, right? You know, we'd want a pattern that looks something like this. We'd be pretty unhappy if they were all pretty spread out, right? We'd say, okay, that, you know, that's not going to be a very great kicker, right? Because that's a pretty wide curve. Okay, so intuitively we know that, you know, less deviation is better, right? But let's try to quantify that idea a little bit. So we can, well, we've quantified a little bit already with standard deviation, right? But let's try to quantify this a little bit more, because we know what the target looks like, right? In football, the uprights are 3 feet, or I think they're about 18 feet apart from each other, right? So the target is 18 feet wide, okay? All right, so we want to get some sense of, you know, how this particular, you know, distribution sort of fits with an 18-foot target, right? Ideally, again, you know, we'd like a really tight distribution and a really big target, right? It's really the ratio of the two that we care about, right? The distribution is a little bigger and the target's like really huge, that's okay, right? But if we have a smaller target, we want a smaller distribution. So again, that's, you know, that's really what we're interested in. So process capability is just the width of the target over the width of the process. or the amount of variability in the target versus the amount of variability in the process. So if our target is 18 feet wide, right, put that in the numerator, and then we got to have some quantification of how spread out the process is in the denominator. And for that, we use the standard deviation, right? We actually use, if it's process capability, C sub P, we use 6 standard deviations. So 6 times our standard deviation of 3 for that process is 18, right? So here we would have a C sub P of 1. What does that mean? Think about that, right? That means that the target and the process are the same width. What do I mean when I say the process is the same width as the target? Well, I mean, 3 standard deviations of the process, right? And why is that important? Because remember, basically all our output is going to fall within 3 standard deviations, right? So pretty much all of our output here, every one of our kicks is going to fall within 3 standard deviations. Every one of our kicks is going to be between the uprights. Because the ratio is 1, right, and the target and the process are exactly the same width, we know that some of the kicks are going to be really close to being outside, right? Most of them are going to be in here somewhere, right? But there are going to be a few that are right outside. So an even bigger number would be better, right? An even bigger process capability number would be better. We could get that by expanding the width of the target. If the target were 20 feet instead of 18 feet and nothing had changed about the process, that'd be even a little bit better, right? Because we'd have this kind of buffer area out here, right? Or we could shrink up the process, right? If we had a field goal kicker, we could do something with our kicker. Maybe we replace the holder or something like that. I don't know. If we could do something with our kicker to reduce this spread, get the spread looking less like that and more maybe like that, well, what would that do to the equation? That would decrease the denominator, right? And that would be good too. That would also increase the process capability. Again, that's all that C sub P is just the width of my target divided by the width of my process, right? And I want to have a big fat target relative to my process. Ideally I don't want any variation in my process, but we know that with any process we're going to have some variation, but less is always better, right? That's all it is. It's nothing more than that. If you understand that, you'll have a lot easier time dealing with this concept.